All right, let's dive into something really fascinating today. We're going to look under the hood at the architecture of a new kind of road safety system. And this thing is radical because it connects the dots between law, policy, and technology into one single automated pipeline. So, let's see how they actually pull it off.
You know, it's a bit of a paradox, isn't it? We've got these incredible high-tech cameras, we have powerful AI, we're swimming in data. So why are our roads still such a challenge when it comes to safety? Well, the answer might surprise you. It's not about getting better cameras, it's about building a better system.
And that right there, that quote, is the key to this whole thing. The problem isn't that our technology isn't good enough. The problem is that all the pieces are disconnected. You've got the courts issuing orders over here, governments writing policies over there, and engineers building the tech somewhere else. And they just aren't talking to each other in a cohesive way.
So here's our game plan. First, we're going to reframe the problem, see it as a system. Then we'll compare the old, broken way with this new pipeline. After that, we'll see how law literally becomes code, explore the brains of the operation, the GenAI engine, figure out what it takes to make this legally solid, and finally, we'll talk about what this means for the future.
Okay, first things first, we have to completely shift our mindset. We need to stop thinking about road safety as just some widget or another feature you see on a city dashboard. What we're really talking about here is a classic distributed systems problem. Just think about the layers. Way up at the top, a court issues a directive. That needs to flow down and get translated into specific government policy. And that policy then has to be turned into rules that technology, like cameras and AI on the street, can actually understand and execute. If any of those connections are broken, the whole system just falls apart. And to really get why this new approach is such a big deal, let's put the old way side by side with this new integrated pipeline. The difference? Well, it's night and day.
Okay, just look at this comparison. On the left, you have the traditional way. A court says something, somebody eventually writes up a policy memo, and then teams on the ground have to try and figure out what it means. Technology is usually an afterthought, just bolted on at the end. It's slow, it's manual, it's messy. Now, look at the right, the systemic approach. The court's directive immediately informs the policy logic. That logic generates the rules, and the AI executes those rules. It's a clean, direct, and measurable line from intent all the way to the outcome. So how do you actually build this? Where do you start? Well, it all begins with the most abstract part of the puzzle, translating the intent of the law into something a machine can actually execute. And this diagram just lays it out beautifully. See, it kicks off with a judicial directive, something high-level like reduce fatalities. That gets translated into specific policy rules. Those rules are then written as code, machine-readable code. The AI system then uses that code to enforce the rules on the ground. But here's the crucial part. The results, the violation data, get fed all the way back to the top. This creates a feedback loop, so policymakers can see if their directives are actually working and fine-tune the system. Now, the absolute key to making all this work is a concept called policy as code. This is the secret sauce. Think about it. Legal language is full of ambiguity. It's designed for human interpretation. Policy as code is the discipline of taking that fuzzy language and turning it into precise, structured rules that leave zero room for misinterpretation by a computer. This is really where the legal world and the engineering world shake hands.
And here's a perfect, concrete example. You take a legal phrase like strict enforcement of red light violations at high-risk intersections. What does that mean to a machine? Well, it becomes this structured object you see here. The violation type is signal jump, the locations are clearly defined. You can even specify a confidence threshold for the AI and define the exact penalty. The abstract idea becomes totally concrete, totally executable logic. Okay, let's talk about the brains of this whole operation. We're not just using any AI, we're using generative AI. And it's not just here to spot a violation, it's acting as a pretty sophisticated reasoning engine. And this is such an important distinction to make. Your standard machine learning model can answer a simple yes-no question. Did a car run a red light? But the GenAI reasoning engine goes so much deeper. It asks, why do cars keep running the red light at this intersection at this specific time of day? And based on the policy we've been given, what's the right thing for the system to do about it? It's moving from simple detection to true contextual understanding. So what does that reasoning actually look like? Well, it looks like this data. The AI doesn't just spit out the word violation. It generates a structured response. See here? It references the exact policy rule it's using.
It identifies a specific risk pattern, like, oh, this is a repeat offender during rush hour. And based on all that context, it recommends a specific action. It's making a nuanced, policy-driven decision.
Of course, none of this matters if it can't hold up in the real world, and the ultimate test is a legal challenge. This means that explainability, the ability to show your work, can't be something you tack on at the end. It has to be a core engineering requirement from the very beginning.
So what does that actually look like from an engineering perspective? It means for every single decision the system makes, it has to capture evidence like photos or video clips. It has to record the AI's confidence score in its own decision. It must provide a direct link back to the specific policy rule that triggered the action. And all of this information has to be stored in an immutable audit log, something that can't be changed or tampered with later.
And this is what it all builds up to, a court-defensible data packet. It's all right here. You've got the final decision, the exact legal basis for it, direct links to the raw evidence, and the system's confidence level. Everything a judge or lawyer would need to understand exactly what happened and why is neatly packaged together, completely transparent, and ready for scrutiny.
So let's zoom out and look at the big picture here. The future of public safety isn't about just bolting on more features or buying fancier cameras. It's about a fundamental shift in how we think, moving toward true holistic system engineering. And really, this is the main takeaway. This is what it's all about. We're not just adding AI to a camera. We are building systems that can take a high-level idea from a judge and turn it into code that is executable on the street, totally explainable in a courtroom, and smart enough to adapt and learn from its own data to get better over time.
And that really leaves us with one final big question. If we can apply this kind of end-to-end measurable and adaptive systems thinking to something as complex as road safety, what other public services could be completely transformed? What else could we redesign from the ground up, not as a collection of features, but as a complete, connected system?